Okay, I'm going to recap all the steps in the assignment. I'm going to be running through them fairly quickly in an attempt to make a video that's fairly concise. So you can refer to this when you lose track of where the buttons are, and I'll say a little bit about format as well. I'm going to start off right from the first stage here of just building the mass in Revit. So I'm going to start with a new file. If this interface looks different, that's because this is the Revit Autodesk 2019.2 update, and they changed the home screen a little bit. You can still carry on with all the things that I mentioned if you're still looking at the older interface. The version 2019 or even any version from last year would also work. There have been some interface changes and some button changes in 2019 though, and I'll point those out as we go. But I'm just going to start off with a brand new Revit file. And if your interface doesn't look like this, you can always go back to the regular, just regular old file, new, and project. And I'll just use the default US Canada template. And that template happens to be in metric, which might be a bit of a departure from the way you guys are working, but the units aren't really going to matter too much here. The other thing is with this template, I just get 2 levels. So I'm just going to start off by adding an additional few levels. I'll put level 2 at 3000, and then I'm just going to add by hitting LL, which is the keyboard shortcut for creating a level. So it's important that you use the level tool and not copy levels. You won't have the ability to do a mass floor if you copy a level. You have to actually have a level in there with a corresponding floor plan. So again, I'm in the south elevation view. I adjusted level 2. Now what I'm going to do to create additional levels is click on Pick Lines, specify an offset to match 3,000 millimeters, which is 10 feet roughly. And I'll just take this up to, well, I'll say level 5. I probably don't need anything quite that high, but I'm just going to put a few extra in here. So with the levels in place, now I'm ready to start the mass. And I'm going to just go to my level 1 floor plan view for this. And to create the mass, make sure you're using the Massing and Site tab. There might be a bit of a temptation here to go to the Architecture tab and use the Model in Place generic component. This won't have the same effect. You can't do any energy analysis on this, and you can't do the mass floors. So for the masses that we want to use for analysis, we want to have to make sure that you go to Massing and Site and then choose In Place Mass. Once you do this, it'll usually ask you about visibility settings and give you a default name for the mass. Just accept both. Click OK, and then you're in sketch mode where it's anticipating that you're going to create some massing elements. So I'm going to keep this really simple and just do kind of the 3 basic things that you would do in here if you're creating a mass object. I'll click on the rectangle tool to start this, and I'm not really too worried about specific dimensions here, but I'm just going to make something that's roughly let's say 7 meters by about 12 or about 20 feet sort of in width, so somewhat close to what you're dealing with your projects. And with that initial profile in place, I can now select it, and then I'll look here for the Create Form button, and this is what extrudes it. So if I click on the top part of that button, remember, get the top part, I'll talk about the lower part in a minute. Click on Create Form, and it just gives you a default kind of randomly assigned height. If you want to control it and do something more specific, just click on this number, this temporary dimension that appears near the vertical element. It says 4,000 at the moment, and I'm just going to change this to, let's say, 6,000. Now, if I want to add additional detail to this, like, for example, if I want to mimic a gabled roof, I would just keep adding additional profiles and then extrude them. So, for example, I could click on the rectangle tool again, and then I'm just going to rely on the snaps that take me to the end point and the midpoint. I'll click on that rectangle, repeat the same process, create form, and then to create the gable roof, maybe I'll just knock this back down to 3,000 for height. And if I want to create the slanted roof, all I have to do is just wait till I see an individual edge or a segment. If you're not getting the element that you want to edit, you just hit your tab key, and it'll shuffle between all the different sort of topology levels. So there's an edge or a line or segment, and there's a face, or what it calls, let's see, it calls a form, so that's the top, and then there's also the element, which is the full object. So if I want to just edit this edge, just pay attention to the prompt on that dynamic input that pops up, and I'm just going to drag this down to create that kind of gabled roof. And if you want to be real specific, you've even got temporary dimensions here. So if I want that to be 500, just rely on the numeric entry. Now to create the other side, I could just select that that element. So make sure you get the entire element. And then at this point, I can use one of my editing tools, like mirror draw axis, or I can just create another one beside it. So I'll click on the rectangle here and just repeat the process. So I'll click here at this point, and pay attention to when you're creating these elements. Watch the blue highlight will let you know what the current reference plane is. So you may have noticed when I began to create that rectangle, see how it kind of selected that vertical face on the left side there. That means that when I draw this, it's going to be vertical. So just pay attention to that blue face and make sure that you get something that's going to be horizontally oriented like that. So same process, I'll click on this rectangle, create the form, modify the height to be 3000, and then select the edge on the right, and then just use the gizmo to initially drag it down and then finish it off with something more precise by entering 500. So that's the first step, basic extrusion. Just create a 2D profile and extrude it with create form. The second step might be modifying it by selecting edges or faces or even points. So you can actually select points as well. I'm not going to do that for this one, but that option does exist. And now, just to simplify this, I'm going to use the join tool. So right here I have join, and then I can just select the bottom extrusion, join it with the right side gable, and then do the same thing with this one on the left. So it just simplifies the whole mass. And then the last thing that you might want to do to create the appropriate mass for your buildings is just to use that same rectangle tool. And I'm going to draw a rectangular profile on this vertical face, something like that, let's say. And then when I select it, instead of using the default form of the create form tool, I'm going to use the void form. And that will create this kind of recessed void. And I will leave it at that. So there's lots that you can do to sculpt that and make it something more specific, more particular to whatever building you're designing. But those are kind of the basic steps for making the mass blocks. So when that's done, I'm going to click on the green check. Now notice that I didn't create those gabled elements on top as separate masses. I'm trying to do this all as one object. So when I click on the green check and I'm back in the regular project environment, if I select that now, it's all selected as one object. If you select your building and you notice that you have to select several different masses, you're going to get some problems with your energy analysis because it's going to try to analyze each one separately. And where they share a face, like a roof and a floor, let's say, it's going to try to analyze between those, and you'll get some conflicting results. So keep it simple, just one mass. And then the last thing I'm going to do real quickly before I start with the analysis is I'm just going to create some basic massing elements around that would represent surrounding buildings. So on the Massing and Site tab, once again, we'll click on In Place Mass, accept the default name that it gives me. And there's no reference here for what I'm doing. I'm just doing it fairly randomly, but let's just say that these all represent surrounding buildings. And these are important because when I do my solar radiation analysis and then the energy analysis, the shadows that these buildings cast and maybe the wind that they block for another analysis step that we'll do later, those things will have an impact on the analysis for the building at the center here. So notice that with all of these, I just did them as one mass block in one mass block session. You have to click on each individual little shape here and extrude them separately, but when I finish, these will all be selectable as one mass object, which is fine because I'm not doing the analysis on them. I just need them there for a little bit of context. So I'm just kind of assigning some random extrusion values here, and then we'll see that these have an impact on my solar radiation analysis in the next step. So there we go, all set up. I'll click on the green check. And again, all of the surrounding elements select as one single mass object. They all have grips if I need to make any sort of modifications to them. And then this object that I want to analyze selects as its own sort of entity. So when the massing's done, we want to start with solar radiation analysis. That's available here on the Analyze tab. And this is possible because we hunted down the solar radiation analysis tool, which was part of the Insight 360 plugin. And all we did there is we just did a Google search for Insight 360 Autodesk. And that's how we can see the solar radiation analysis tool here. And then it also adds a couple tools here on the energy optimization panel. So I'll start with solar, and when I click on that, it's waiting for me to select faces on the building. So what I'm going to do here is I'm going to click on this portion where it says surfaces and change the setting from all roof exterior surfaces to all mass faces. Sorry, to user selection. I'll get a little prompt here about choosing the faces. I'll just check the box so it doesn't show me this again. Turn it off. And now what I need to do, just a second here, let me back up a little bit, is I want to just select the building in the center here. So I'll do user selection, and now it's assuming that I want to do everything. Just a second. There we go. User selection. Now with the cursor you can see the little plus symbol. It just assumes I'm going to do multiple faces, so I click on the vertical face here and just keep making selections as I go. I don't have to hold down my control button. And just pay attention to the blue highlight. That's how you know the face has been selected. Use your tab key if you can't quite get it to select the face that you want to choose. And just one more to go here. All right. There we go. So all of the faces above grade have been selected. I don't need to select any of the other faces from the other mass objects. This one's now ready for solar radiation analysis. It's waiting for me over here on the left to click finish. Just be aware of that. It's not a really obvious button, kind of hidden where you wouldn't expect it to be, but click finish. And before I update to actually run the analysis, I'm just going to expand the settings here. And this will allow me to choose by clicking on this little button over here on the right, so I can specify a style. This will allow me to choose my solar analysis default. And once that's selected, I can click on my color tab. And then I'm just going to change these colors here to be something a little bit more intuitive, like yellow, red, and then blue at the bottom, from warm to cool. So blue indicates less influence from the sun, yellow indicates more influence. Once that's done, if you think your laptop can handle it, click on this little settings button here, and you can increase the analysis grid resolution down here. And maybe have a fire extinguisher ready for your laptops. This will cause them to work harder, so be aware of that. It's not a requirement for this assignment, but it adds a little bit more detail and gets rid of those kind of strange triangulation graphics that you may have noticed. So I will apply that. I'll click update. I'll see the little spinning donut. And then in a second here, it's going to add the color. There we go. So I'll turn off my solar analysis window. Remember, there's a little legend here that you'll need to kind of drag closer to your building. In the screen captures that you do for your PDF report, you don't need to show the surrounding buildings. We're just interested in seeing your main building. And that being the case, you'll want to crop this. So down here on your view control bar, there's a set of cropping tools. The one on the left at the moment is not cropping the view. So click it once. And then right beside that, there's another set of cropping bars with a little light bulb. So if you click on the light bulb, it'll show you your crop region. And then you can just shrink this in so that we can focus on your building. And like I said, just drag that legend in there as well so we can see what the values represent. So this would be the first step in doing the screen capture. Let's use the export command. So if you go to the File tab over here on the left, and then drop down to Export, and then you have to kind of just hover near the bottom, and it will scroll down to where you can see Images and Animations. Choose Image, and just make sure that you give it enough pixels here. So crank up the resolution here where it says Image Size, and let's make it a minimum of 2500. And then we'll just set a JPEG lossless format just to keep the file size small but the quality up. And then give it a name, and I'll dump this on my desktop. And I'll call this my solar radiation analysis image 1. And then it's just going to package that up when I click OK. It's not a big image to create, so that's the first part of it. So for the second part, just make sure that you use your view cube. It's probably the easiest way to do this. And just click on another part of the view cube so it spins around. Now you'll probably see that your building goes out of view, but just adjust the crop region here. And make sure you include the legend as well. That may have disappeared from view. If it does, just click on this crop button down here so it doesn't crop. And then you can locate your legend, drag it back down, and then crop again. Change the crop region, and then just do exactly the same steps by clicking on the export command to create an image showing that information. Okay, I'm going to turn off the crop, and I don't need to see the crop region either. So that's solar radiation analysis, and remember that you're going to do 2 of those images for each of the masses that you create, southeast and northwest, or whatever combination you like, just so I can see all sides of the building. All right, that's solar. The next part then is we get into the energy analysis. And to do this, we have to first look on the energy optimization panel. And if we click here on this little globe with the orange pin, it will allow us to choose a location. And when this pops up, we'll see that the default is the Internet Mapping Surface. And it's going to choose Boston by default, so we're just going to type in our location. And we'll hit search. And it just wants us to specify whether we mean Calgary, Alberta or Calgary region. Not really sure what the difference is there, but I'll choose the top one, Calgary, Alberta. And then it displays all the weather stations for which it has weather data in the area. I'm going to choose this one. And this is 14882. I'll click OK. Now it loads in everything that it knows about climate in that spot. And we're ready to start setting up the energy model. First step is to click here on Energy Settings. So if I click on that button, I've got 3 things that I want to set here. The first one is I want to click right here where it says Mode and change this to just be conceptual masses. At this point, we don't have any floors, roofs, anything with any data about R value or resistance or conductivity. So all we're doing is just analyzing for shape, just the masses. So use conceptual masses is the first change you want to make. And then you can click here on the Edit button. And we want to eventually change target percentage glazing. For some reason, the first time through it doesn't show, but I'll exit out of here and come back in, and then you'll see that it's editable. And the other thing I'm going to do is I'm going to change the building type. So if you click on where it says office at the moment, it jogs a little bit to the left there, but just change office to whatever's more appropriate for your building. And for this one, we'll do a single family. I'll click OK again, click OK again. And before I start doing the analysis, I'm going to go back in here and change the percentage glazing opening. So I'll click here on Energy Settings again. I'll click on the Edit button. And this is where, for some odd reason, now it's editable. So I'll type in, let's say, 30% here. Doesn't matter to me which numbers you use, just be consistent all the way through the analysis of whatever your masses may be. So I'll click 30%, click OK. And it still looks the same. It still shows the solar radiation analysis. It's going to change when I click on Create Energy Model. So if I click on Create Energy Model, oh, I forgot a step, sorry. I forgot to do the mass floors. Before you do that, click on Mass Floors. So select your mass, and then click here on Mass Floors, and this divides it up into the different levels. And I'm going to choose level 1, 2, 3, and 4. There we go. So now, because I had initiated the energy model and now I've added these additional floors, you can see that it's kind of split it up into what look like windows. Now, at this point, you might look at that and say, well, that's not where the windows are in my building. This is just simple sort of general calculations on how much sunlight might be coming in the windows based on a rough percentage. So later on, we'll actually leverage the information from your design and get more specific about exactly where the sunlight's coming in the windows. But for this sort of initial energy analysis, this is fine. All right, I'll go back to my Analyze tab. And now, after I've created the energy model, I can click on the Generate button. And this adds just a little bit of a modification. You'll see it change slightly. And this is just preparing it to do the optimization step. So having done the Generate stage, now I can click on this little button beside Location. And this will send it off to the Autodesk servers. And it's going to take probably 5, 10, 15 minutes for this analysis to run. So I'm not going to wait around for that to finish, but I'll show you one of the ones that has been completed. and I'll show you what information you need to extract from this. So this is one that I just ran earlier, and if you click on them as they appear here in this little gallery window, what you'll then see is a graphic 3D representation of your building here in the top window, and you'll see a little number displayed over here in the left. So this tells me that this particular building, and again, this is not the one that I just did the solar radiation analysis on, but just to kind of speed things up and show you what the end result will be 10 minutes from now. This is an earlier mass, and this one is consuming or costing 37 United States dollars per square meter per year. If you click on that, it'll switch over to kilowatt hours per square meter per year. So let's use that one instead. And what we're doing, of course, as we run our various massing analysis energy steps, is that we're just trying to see what the overall impact of the shape change will be. Ideally, we're trying to get to a shape or an orientation that will consume less energy. So when you get to this stage, there's no export button here, but you can just use something simple like the Windows snipping tool. So down here in the lower left where the Windows icon is, you can click, type in snip. You'll see the snipping tool, and then I'm just going to click New, and I'm just going to select this top part. This is the crucial bit right here. What's down below we'll get to later. That's the more in-depth analysis of all the individual components in the building once we've got those built in Revit. But at this point, we just want to see this crucial bit of information here. What's showing as the kilowatt hours per square meter per year. So once you've done a snip of that, you can click File, Save As, save it as an image, and I'll just call this my energy use intensity for mass 1. It's a JPEG file, and now it's ready for me to compile in a report that I can build in something like Microsoft Word. So I will turn this off, and I'm going to go back now to Revit. And I'm going to export this so that I can do the analysis in Flow Design, which is the last step of the assignment. So in Revit, I just have to go to File, Export, and choose the FBX format. So click on FBX. It'll ask for location, of course, and I'll just call this Mass 1 for Flow Design. It's an FBX file. If you have a lot of detail in your file, curves, lots of complexity, then you'll want to use this level of detail command, which just makes sure that your curves stay smooth and that you get all the detail that you need. Generally speaking, though, for massing, you don't want a lot of detail. You want to keep this fairly simple. I'm going to click it anyway. I'll choose Save, and it's all ready to look at now in Flow Design. Remember that Flow Design comes from the Autodesk student site. So if you just Google Autodesk student, take the first link, the first hit, and what you'll see on the home page is a list of the most commonly downloaded software packages like Revit and AutoCAD and 3D Studio Max. If you just scroll down further, you'll see the full alphabetical list of all that's offered, and the one that we're looking at is Flow Design. You have to be logged in, use your education email address, and it's a fairly small download. Install that, and then we'll go into Flow Design. And when you get it installed, if you click on Autodesk, you'll see Autodesk Flow Design listed. It's a fairly light program, but it is a standalone program. It's not a plugin like we saw with Revit. So if I click on Flow Design, it'll start right up. It goes right to a simple home screen, and all you have to do is just click on Local, locate your mass. There it is right there. And this is what you'll see, or something like this. Okay, so initially it's not going to be oriented properly. It's going to be standing up vertically like this. The first thing that we're going to do is we're just going to tip the model back down so it's horizontal. And the way that we do that is we click on Orientation, and we're just going to rotate it 90 degrees on the X angle. So just highlight X angle, type in 90, and you'll see it's now properly horizontally oriented. I'll click OK. It's going to think a little bit, And now what we're going to do is we're going to change the orientation of this simulation plane. And we do that by clicking here where it says side, and we'll choose top. So what's happening is that it's doing a two-dimensional simulation plane, and it's running, it's treating the air as if it's fluid. This is computational fluid dynamics, so it's just basically assuming that air is going to behave like fluid. And what it's doing is it's running a constant stream from this side over here on the left. And as it moves through your neighborhood here, you're going to see the impact of your building and the surrounding buildings on these current patterns, on these airflow patterns. Now, if you run across a situation like this where maybe it's kind of clipping your building a little bit, all you have to do is just go up here to this little button over here on the left. Sorry, this one here. And we're going to select tunnel bounds, and then you'll see some grips that allow you to drag this out a little bit. So first step was tilting the neighborhood or your model. Second step was tilting the simulation plane so that it shows top instead of side. And then if you need to do further modifications, you can just click here on this button at the top, which is the visibility settings, and this will allow you to see the bounds of our little simulation plane. And once those are set, you can come back here and just turn them off. Now, it's just going to constantly run this simulation. It's going to run from this side. So if you want to kind of mimic the wind coming from another direction, you have to rotate your model. Now, what generally speaking is the prevailing wind pattern where we live? Where does the wind come from? Northwest, right. Which is why those of you that live in the Northwest, might be going home to more snow today than the rest of us. But so just be aware that we want to kind of get a feel for what the wind pattern is going to be like typically, but you can also kind of experiment and see what it would be like for wind to run from another direction. If you want to do that, you have to change the orientation of your model. So I could do that by going back here to the orientation button and then rotating on the y-axis. So if I just use the slider, you can see that it rotates my building there and the surrounding buildings. And remember that the wind is always going to come from that kind of upper left direction. So if I want to see what it would look like from this side, just change the orientation on the Y. And then it'll just run the simulation again. You might have to, after you've done that, go back here to visibility and then see the tunnel bounds and expand them a little bit. And once you've done that and it's updated, then you can turn those tunnel bounds off. And what I'm looking for here, once again, is just a screen capture. It does have the option of doing an export or a save image, but it really is the same thing as just doing a screen capture. So either one works. And so I'll just kind of show the same method here by clicking the snip tool and then just clicking new. And I want to just capture what this, get the legend in there as well. Of course, it's going to show the meters per second airflow. I kind of clipped it there, but you get the idea. So do a screen capture that shows the legend. This will give us a feel for where we have a little bit of extra turbulence. So as the wind moves across our building, we're getting a sense for where it may be. Maybe if I want to do like a deck or a space that people will be kind of lingering, sitting, maybe a balcony, something like that. This will help me get a feel for what the wind patterns might be like in that spot. It also gives me a little bit of a clue as to whether I can do passive ventilation or not. So what spots in the building might be good for opening up a window and introducing a little bit of air. As for the height, one last modification you might need to make. You may notice when you do this, that the simulation plane is up above your neighborhood or your building. So if that happens, all you have to do is just click on this little kind of greenish blue node at the back on the vertical axis line and just drag it. So as you do that, you'll see it going higher or lower. And as for what vertical plane you choose to do the simulation at, that's your call. Just do it where there's maybe a little bit more turbulence, where it's kind of telling you a little bit more about wind patterns around your building. This obviously up here doesn't do us any good. We don't want to see that. But we also don't want to see it right down at ground level either. Think about again where maybe you're going to have your occupants sitting on a balcony or a deck or something like that. And this will give you a feel for what the air pattern, what the circulation patterns might be like around your building. Okay, and that's it. Those are all the steps of the first phase of this assignment.